Okay, part four. We'll be creating planar surfaces, and we're going to introduce the shader component and describe how to create some decent looking materials in Grasshopper. So, in the last two sections, we generated a series of triangular faces and then offset those faces and filleted the offsets to create some inner curves. We're going to need both of those sets of curves, the triangles and the offset fillet curves, to create our planar faces. So each one, and again, let's switch back to the single surface just by overriding that server. I'm going to zoom in on this little guy. So each one we need to create a group. We're going to do this by joining these two curves, even though they don't physically intersect. If you join them in Grasshopper and then pass them into the planar surface component, you'll get a trimmed planar surface. So there'll only be surface kind of in the region between curves, and we'll have an aperture. That's just what we're going for. So since we're dealing with lists, the way that we're going to have to do this is to go into the Sets tab, Merge again, and now it's going to be important to graph these. So we'll put the two inputs into D1 and D2, and let's just try it without grafting just to see what happens. All we need is a join. This is going to be very quick. Curve join is right there in the utilities. So that completes successfully, and if you see what we get out of here, we get a list of curves, two polylines and two closed planar curves. So if we go into a surface, a planar surface component with that, we're going to get, well, we do get some planar surfaces out of here. Let's try it with the whole. Let's try it with the whole population. I think it falls apart when you give it everything. Nope, it's working. Beautiful. So I thought we were going to have to get into some data trees there, but it's looking like we are going to get away with it just with lists, which is even better. So there we go. We're essentially done. So the last part of this is going to be to create some nice materials, some colors. So up here in Special, there's a custom preview component, and this doesn't have any outputs. It just renders geometry on the screen. The what we want to the geometry we need is are those planar surfaces, and it's asking us for a shader. So there's a couple ways you can generate these. In Special, again, there's a color swatch, and you can just plug that right in there and get a kind of flat, opaque color. This is similar to the group interface when you right click on that. And I'm going to hide everything at this point, so we're just seeing our rendered preview geometry. If you want some transparency or a little more control over the material, in vector color there's a create material component, and it asks for diffuse, specular, and emissive channels, as well as a transparency amount and also shininess. So let's just use white, and whoops, keep that the geometry. That wants to be the shader. You can see it also, it already it kind of changed how it reflects light. But let's just introduce some transparency. So slider equals 0.5, and that should give us some transparency. Sometimes when you get too many curves on top of themselves, you get some kind of strange graphics. Like all the curves will come to the front of the screen, and some graphics cards handle this better than others. But in any case, this gives you a way to create some decent looking geometry in the Rhino viewport without baking. You can mess with these to get pretty specific, but just besides creating geometry that's pleasing on the eyes, this is a great way to organize things. You can basically group by material or color or whatever you need to do to get your point across. Okay, so that's about it. Let's give this a title. This is just going to be create planar surfaces and render. And since we don't have an output for this function, I usually group the preview and make it a kind of a hot pink or a magenta kind of a color, something that really pops and will be easy to spot. Um, yeah, now we're talking right in there. And lastly, I'll just wrap all that up as one more little group to define the function. Okay, so this pretty much brings us as far as the guys over at Design Reform went. Very different way of organizing the file. Might have seemed a little laborious, admittedly, but everything's working very smoothly. I think we've made the file very legible, and in the next two parts we're going to look at different ways of creating the offset amount. And I think the logic of breaking out these these commands into functions will really become apparent. So that's it for part 4. Parts 5 and 6 will go into offsetting by area and offsetting by distance to an attractor point.